can almost picture that happening.
Okay.
Okay. All right. Well, I'd like to just welcome everybody to this week's edition of Steel for Lunch. And as I've said at the beginning of all of these, this is a relatively new program that we have. We're quite excited about it. We get really interesting speakers talking about a variety of different things, and we'd like to ask everyone in attendance today to talk about Steel for Lunch to their friends and associates, and try to get everybody to sign up for the Steel Center Bulletin and check the Steel Center website to find out when the next Steel for Lunch presentation is. So I'm delighted today to invite Adam Kozousek from the Czech Republic, who is working for IDEA StatiCa, a very innovative software that the Steel Center has engaged with, and we're doing some research related to it as well. Let me just introduce Adam. Adam is a structural engineer with over 10 years of academic and industry practice. He has a wide range of experience in different branches of civil engineering, including structural and geotechnics. Adam graduated at the Czech Technical University in Prague and gained his skills in various jobs. He's been working as a product engineer at IDEA StatiCa for over 3 years, and he's part of the sales and support team providing customer technical support, participating in the development of the program, and giving training and presentations about the software. He's a big fan of finite elements and building information modeling and all sorts of smart applications. We're looking forward to hearing more about this software. And welcome, Adam. And I know that it's well into the evening, so thank you again.
Thank you. Thanks, Robert. And greetings, everybody. Greetings from my side. My name's Adam from IDEA StatiCa company. And I think it's the time to share my screen, right? Greetings from the center of Europe. I'm having the Friday night party now here with you. So excited to screen number 2, that's this one. I'm excited joining you here. It's a pleasure. And now let me set this here. Okay. I guess you now see my presentation screen, right? And you can hear me well?
We don't see your screen yet.
No? Okay. Oh, right now?
Yeah, perfect.
Cool. All right. So about today's content, I've prepared 2 presentations for you and a short demo. It's about the CBFEM method. That's the technology that was developed within our company, and the core technology that we use for the software called IDEA StatiCa that we also develop in here in our office in Czech Republic. So let me start about the method. What is CBFEM? This is very unique, innovative technology, a component-based finite element method. That's the full name of that. And what it does, it allows a design and code check of steel connections according to codes and national standards. And the advantage of this technology is that it can do any topology, any loading, and it can do it pretty fast. And it supports various codes at the same time. And how did we figure it out, or why did we come with that? There was a huge development of finite elements in the past decades, of course, used for structure engineering as well. You've got all these softwares like SAP 2000, ETABS, and I don't know, many of them worldwide. And the core team of our development worked in this finite element spreading these past decades. And at the other hand, they were thinking about the design of connections and about the component method, the well-known and quite simple one, and about the weak points of this method. And so they somehow came up with the idea to put those two together. And that's how the CBFEM method was created. And it's a quite new technology. And in the standards, in the codes, it's not really described. For example, regarding Eurocode that we use here all around Europe and in the most countries in Europe, it is already based in the draft of the update of the Eurocode that it is possible and even recommended to use this design-oriented finite element analysis for connection code checking. Now, how does it work? What's behind this? This is something a bit different from the standard finite element analysis softwares, like you can imagine ANSYS or Abacus. Those programs are pretty good in simulating the real behavior of the I know, like deformation behavior of connections or steel structures or whatever. But for code checking, this is not really of any use, because you have to take into account all these code-defined safety margin and safety factors and so on. So that's why this is a bit different approach. It used the design-oriented finite element analysis, which takes into account all the code requirements, and this is included in the method. Now, it works, as I said, based on finite elements. So imagine having, for example, anchoring of a column. This is all separated into finite element components, and there is the analysis model created automatically by the software, and the analysis is performed. You will see this all live. I'll be showing you in a couple of minutes. And how is the model of, for example, an anchoring or a steel joint created? There you have plates, such as end plate, fin plate, or whatever. That's a 2D shell element. You've got the 2D finite elements. Then members such as columns and beams and so on, for example, the I section or whatever, those are these shell elements connected by butt welds. Then you've got bolts, anchors. Those are kind of non-linear springs. And the weld elements are just linear special finite elements with constraints connecting the shells of the plates. The steel material within the model is described as plastic nonlinear in way of the material, not in the geometry, but partly we also cover this nonlinear behavior of thin-walled or closed cross sections and so on. So this is partly also covered. And the material model is, as I said, design oriented, taking into account all the safety factors. And the code check is not based on stress, as you would maybe guess, but it's rather based on the equivalent plastic strain. And there is a, which is based in the codes, American, Eurocode, yours as well, as 5% of plastification of the material. That's the limit, which is pretty reasonable and economical, and it allows to use much more capacity of all the components in the design and code check. Now about the welds, they have their own finite elements. They respect the geometry, of course, also stiffness and ductility of the real weld. And what more, one of the, let's say, highlights of the method and the software is that we offer redistribution of the stress along the weld. What does it mean? That was made in about 2 years ago, an upgrade of, I think, version 8 of IDEA StatiCa. We were thinking about how to improve, how to match better the real behavior of welds, because if you would, assume elastic or just plastic behavior of a weld, then the real capacity is much higher. So we're thinking how to boost that, and came up with this plastic redistribution. And that basically means that when you have a weld, for example, there you have an image of an I section of a base plate, and there's a fillet weld along one of the flanges. And now you start loading and increasing the load of a moment, started at 50 kilonewton meters in this case. And what's happening is that in this finite elements, that there are 9 to model the weld. You're getting the high stresses at the edges of the weld, right? And then when you start to rise the load, it's not going to happen that you reach the limit of the weld resistance with this edge elements of the weld, but it starts to redistribute. So you're getting higher stress in the elements towards the center of the weld. And then you go on, and at some point, in this case, 125 kilonewton meters, you reach the very limit of the weld resistance. Here, of course, with the edge elements, and then the weld is overloaded and fail the code check. But without having this plastic redistribution, that would happen sooner. I know, probably it's hard to guess now, maybe 100 or 80 kilonewton meters. So handy handy feature. Now, about bolts and anchors, those work in tension, of course. They work as a combination of contacts between the plates that they are connecting, plus the bolts itself work as nonlinear springs. All right, so there in the picture, imagine an end plate or connecting end plate to beams, apply tension on that, and you can see those plates, opening, and those are connected by the bolt element. There's elastoplastic behavior of the bolts and anchors, of course. And regarding shear, again, that's nonlinear spring contacts around the hole, around the opening for the bolts. Those work only on the side where the bolts press or apply tension on the plate opening. And this has been patented. That was a big success because we've got also a US patent for this, and that pretty covers the solution and the whole method. Another part of the model is the concrete block. That's of course the compression only element, works as a Winkler-Pasternak subsoil, and that represents those basically like small spring, represent the formation of concrete block on which lies the base plate. And the tension is of course carried by the anchor bolts. And then you've got the shear force, which is either transferred by shear of anchors, or by bending the anchors, or by friction along the surface between the base plate and the concrete. Also, we can model a shear lock or shear key. All that is possible. And what is interesting in here and different from the analytical models or things that would await or think how this works is are the prying forces or even prying stresses on the base plate. I mean, if you pull, imagine pulling the column or bending it, you've got tension in the anchors, and also the base plate is deforming, right? And since it's deforming, it's producing extra forces in the anchors. So that's the prying forces in the anchors, and also it produces extra stresses in the contact between the base plate and the concrete block. And sometimes it's even like on the parts of the base plate where you would not really await that, like imagine the edges on the pulled part of the base plate, that they like bend and dive into the concrete, and there you get like high stresses. Okay, and so those are like all the parts. And with those, you assemble the analysis model. This is, as I mentioned, created or generated automatically by the software or by the method. And the model is meshed. There's a, of course, meshing engine inside. And this is also a bit different from probably the software that you know. This is special in the way that there is no intersection or no match needed between each element, right? So you have probably you are used to finite elements where you have to match all the nodes and edges where you are connecting plates or separate elements, right? And this doesn't need to be here within the component-based finite element method, right? So this is very special for this. And instead of using that common method, we use this kind of interpolation constraints, how to match or connect those parts together to make it work. You can see it here in detail. This would probably not work in, I don't know, Midas, for example, or the common finite element softwares. And this is something new. We can, show off a bit because a lot of these finite elements use the solvers from 90s, and we moved to another level because we've gotten one of our core developers worked for the aircraft industry, which is always ahead in such manners. And that's where that's the source of the innovation that we used. Okay, and so that's a bit about what's behind or what's inside the CBFEM. How can it help to our engineering society? The method, as it is, covers a couple of softwares today. It was originally developed for IDEA StatiCa software, but it's been already adopted for some years by Hilti, for example, for their advanced Profis software for designing and code-checking their anchoring. So they are using this technology there. Also, advanced design connection, that's actually just a twin of IDEA StatiCa under Greitech company. And also Fast Alpine profile form. They have their special software for designing and code-checking their special thin-walled constructions. They use it for their own production and designing. And why is it so unique? If I would sum this up, what I was talking about, it's a general and robust method based on finite elements that allows design of steel connections and anchoring without any limits at all. Well, it's literally almost at all regarding topology design and loading. So there's a couple of pictures for you to imagine what it's capable of. This is very different from all the softwares that you probably know. I know RISA connection or RAM connection and all those. All of them, they are based on the analytical solution. They use a couple of templates that you have to stick to. So they usually solve or code check these kind of standard connections, the most used ones. But if you want to go a step further, there's no way how to use them. So this is actually, that was the motivation why to start with this software and this method, why to do it, because there was a gap in the structural engineering industry regarding the design of steel connections. And whoop, it's here. Now, of course, the first question the engineer would ask himself regarding such a interesting new tool: is it safe? Can I use it? Is it verified? Can I trust it? Because it's something completely new, something that hasn't been before and nobody else uses. So of course, the answer is yes, because it was very well verified and validated. And it's been a couple of years already. I think it's 8 years when we started with this. And the verification went on in, let's say, 3 or 4 steps. First, the technology was developed, the software was developed, created, and then first step was to verify the all the standard connections that are very well described and very well analyzed in all those design guides and codes and those repeating ones. And so that's what we did with, let's say, 100% of match. And then we carried on, and then the second let's say trial was to match the complex models created in ANSYS. So you spent days or weeks creating those models, very let's say research models, and compare with this light and easy to use method within IDEA StatiCa. And again, very good match. So we passed this trial as well. And the third level was a couple of grants that was used for research into universities. There were like 2, let's say, bigger teams verifying and the solution in labs, doing the live tests, as you can see in the picture. And they published a lot of studies from that, a lot of academic articles and so on. So there was really tough testing and verifying it. All this is summed up in this book. From the main author is Professor Wald from the Czech Technical University in Prague. That's one of the leading persons. He also participates in the Eurocode development and so on. So he's very into steel connections and steel detailing and so on. This book is available as well if you're interested. All is all just described there, summarized. And this method is not a black box. It's not the way that we provide the software and say, use this because it's verified and just believe. But it's pretty well covered. There are 2 websites for that. CBFEM.com, that's let's say like the general overview of the method. You can learn something about there. You can get to get some materials like the verification articles as well. And IDEAStatiCa.com, that's the website for the software. And there again, tons of materials, theoretical background describing all parts of the the method within the software. You've got the verification papers and articles from the testing and so on. You've got research papers based on those tests, and more things. And maybe the last thing regarding the verification and validation is, and that's my favorite, that it's been used for a couple of years now, the software. We've got over 4,000 users worldwide, and I think that's the best verification, because there wasn't ever any problem with that. And everybody's just happy with that. So I think that was the last step in the process, and now it's just the big way ahead to continue with improving it and so on. Okay, so that was about the first part of the method, and now let me move on to the second presentation about the software itself. It's the IDEA StatiCa software. We've got application or modules for steel and for concrete. I'm not going to talk about concrete today, just about steel. And so let's go. What is it? That's engineering software for structural engineers, design and code check of joints, cross sections, connections, and details. As I said, more than 4,000 licenses worldwide. That means a couple of thousand of users. The software is validated. We have developed BIM links to more than 20 other softwares, so you can import data. I'll show you this as well. And we are based in Czech Republic. It's let's say a family business. We've got over 40 people, and we've got a network of resellers worldwide that spread the word. And the development is based on 30 years of experience, as I mentioned. There was the core of the team started 30 years ago, and developing finite elements in various applications. And now we are present in more than 70 countries. And why did this happen? Why has this team of people started the business and started the research and development? They were thinking how to participate in the overall improvement of society, let's say, and fill the gap in the industry as well. And so he just wanted to create software to effectively design steel structures or details of steel structures, and let the engineers sleep peacefully without any struggling and so on. So the main thing was to make, or to let the engineers to make the project safe and code compliant. That was also the very number one in the mind during development. Why? Because let's think about it for a second. You've got all these, great softwares, great finite element tools. I know, Septi1000 or whatever, Stat Pro. And they focus on the whole structure, right? So you can model whatever, skyscraper, analyze that, or a bridge, and you're pretty cool. But is that enough? Of course it is, but there's something more. If you take a look, if you would analyze defects on steel structures, or even like collapses and so on, the fact is that they usually happen in the details, like connections or joints, not in the beams or columns. So that's a pretty interesting issue. And of course, any problem is a waste of time and waste of material and so on, so on. So that's also the motivation to why to do this, and why we focus on connections and particular members of steel structures. And so IDEA StatiCa is the first and still the only one to provide such a tool with this capacity inside and this, let's say, professionalism of the global industry players with this unique method. Now the challenge, of course, the always number one, to be on the safe side, means comply with design codes, US, Eurocode, Canadian. We support now 8 national standards. Also, we've got also Chinese, Hong Kong, and Indian, and a couple of more. And the thing is, when you're a structure engineer and you have to code check the whole structure, means all the members, the global model, and all the connections and details. Question is, have you done all of that really? 100%. This is the easy answer regarding the standard or the easy connections. If you imagine, let's say, simple steel hole, standard connections is not a problem. That's, let's say, like everyday meal, right? But then imagine having a complex structure or some nice architecture, and there you have those sometimes very interesting or funny joints and details, and those are very complex regarding the structural design and code check, right? So imagine, what can you do? For the standard connections, you've got design books, Excel sheets, all those tools, all those softwares, no problem at all. It's just like nothing. And for the complex connections, what can you do? When we talked to engineers from the big companies like Arup, for example, one of our biggest customer, they described how they did the design and code check of these complex structures. So what they did is that they used this advanced scientific models using Abacus or ANSYS. There they spent weeks modeling those details, and at the end they got just kind of some output, like stresses in the elements or strains and so on. So they had to somehow take those outputs and somehow translate them or transform them into the forces and the values that you need for code checking. So for that, you have to prepare a special Excel sheet that match just these special details and project. Then somehow estimate sometimes, because that was pretty hard work. And what they confessed, it was very interesting, that sometimes they even avoid using the joint and they had to redesign the detail, spending a couple of weeks of work, right? And then this is another analysis that we've done. If you take a look at let's say some kind of standard steel structure, you've got the majority of connections are standard, just end plates, fin plates, and so on, and a small number of those complex connections. But if you take a look at it from the point of, or from the side of time consumption, you spend 70% of time on your project designing and co-checking these complex ones. These standards are pretty easy and pretty quick to do, right? And that's also another motivation why to create the software. We bring a solution for this. Okay, we bring a tool to do the job easy way and pretty fast, actually in minutes or hours, regarding, I don't know, like optimizing and things. This is an example. We also run quite a couple of webinars during the year, focus on interesting topics. This one was in September this year. This was describing optimization of, you see on the picture, that's anchoring of a column of this structure on the picture. That's some kind of swimming pool hole in Europe. And we made a study how this was, because it's I think 7 years old, how this was designed, what tools they used, and some kind of like how much time did it cost, and so on. And then we tried to reproduce this with IDEA StatiCa. And so we found out that in IDEA StatiCa, to model this, you can see it in the webinar, it takes me about like 20 minutes or even less to do this from scratch. Of course, I was prepared for that, so I did it the very nice way. But anyways, it's just a simple job to do that. And then we focused on optimization. Would it be possible to make it better, the original design, to improve it? So just like 3 minutes, I would just play with the thicknesses of the plates, see where the reserves are, and end up with a bit lighter solution, and calculating about, I don't know, like $2,000-3,000 of saves just on this detail, which is, I think, like 24 times. There are 24 of these anchorings in the structure, and there are more details, of course, where you can optimize. So that's, for me, this is one of the best advantages of the software. It allows you to optimize very, very simply. You can just play with those details. Now, what can be done, or what are the applications of the software? You can model actually whatever you like, all kinds of frames, trusses, footing, 3D joints, anything. And what types of analysis we provide? There's the stress strain analysis, that's the standard one. The code check means you model a joint or connection, analyze, it shows you results and tells you whether you pass the checks or not. That's like the overall check. Then we also provide buckling analysis that shows you the buckling shapes and critical buckling factors of the connections. Also, you can calculate stiffness of your connection that you can apply back into your global model to somehow like improve the efficiency or to match better the behavior of the whole structure. Then there's capacity design that is used for seismic, read seismics, and design joint resistance. That's just it's like extra analysis. It shows you how much more capacity you have in your joint when it's designed this way and when you apply this load that you have. So it tells you, I don't know, like 30% more. Okay, now this software works that there are like starting templates that you don't have to start from scratch with blank screen, but you can choose some kind of basic shapes, basic connections, and just very quickly edit and modify this and get the results done in really in minutes, in a few clicks. Then if you wanna spend some time modeling the complex ones, you use the manufacturing operations, all kinds of cuts, end plates, fin plates, gusset plates, base plates, bolt grids, welds, and so on. And those kind of simulate the real assembly of the connections or the detail on site. So it's like kind of a game that you are building the joint or the connection, and you can do really whatever. Even this huge one you can see on the right side. So the workflow, if you take any template or a blank screen, you edit it, or just step by step add more members, plates, and items to achieve any topology, any loading in a couple of minutes. There is a nice testimonial from Matthew Pierce, Mott MacDonald, another customer of us. They are happy using this tool for their complex joints. What else we have? There was the IDEA StatiCa connection software, right? Next to this, there's IDEA StatiCa member. It's quite a new application, and this was developed and is dedicated to solve all kinds of buckling of members of the structural parts. So you've got beams, frames, platforms, columns, whatever, and there you get all kind of buckling, like torsional, lateral, warping, whatever. This is treated by a couple of softwares already, but what more we offer is that, of course, there's a stress strain analysis if you model such a beam, for example. A buckling analysis, also nothing that special. But then the third step is that what we provide is the full nonlinear analysis that includes the imperfections, geometrical nonlinearity, and all the effects of buckling included. All this is processed and calculated, analyzed and it tells you at the end the result or the output is, even considering all of this, you have passed the checks or not. So this is, as far as I know, none of these finite element softwares for structure engineering offers this. And of course, this is again like free in way of topology and loading and whatever. Those are some examples on the pictures that can be done. Also, it takes into account the stiffness of the connections that you model, like to match the real behavior as best as it can. Other workflows, this is regarding the BIM links. We are linked to a couple of finite element analysis software, how it works. When you install IDEA StatiCa on your computer, it integrates or adds command to your, I don't know, sub 2000 ETAPS. That means you calculate or analyze the structure there. Just click the command, choose or select a node, a structure node, and the connected members. And it transfers the data into IDEA StatiCa connection application. What you have to do is add the design, which is of course not included in the structure software. What you get, what you read from there is the topology, the cross sections, and the main thing, all the loadings. So you import, for example, 20 load combinations that you then analyze and code-check at once, just clicking one button, analyze or calculate. And so you don't have to look for any kind of envelopes or picking the extremes from each combination and combining these extreme internal forces. Like you take a moment from combination 16, you take a normal force from combination 12, sorry, or whatever. You just don't care. You import all of them and you calculate them. And the other advantage of this, besides the ease of use, is that you calculate and process each combination and not the non-realistic envelopes or combinations of extremes. So you don't overkill the design, but you design according to the real load combinations, according to code, of course. Next to this is the import from CAD software such as Tekla, Advanced Steel, Revit. There it's a bit different, of course, because what you import is the design and not the loads. So what you have to do is when it opens in IDEA StatiCa connection is to add the loads. And the best of those two is that you can combine them. If you have a global model of a structure, for example, such as a simple steel hall or what it is, you have this in Tekla, you have this in I know ETAPS, and so you import the Tekla model where you have the design, all the plates, bolts, welds, and so on. And from the other side, you import the same join, the same node from ETAPS, and they meet up in IDEA StatiCa connection, and you can have your coffee instead of typing and preparing the model to be analyzed. Another testimonial from Arab from UK that they appreciate the BIM links, how they helped their workflows and saved the time, the working time, and so on. One thing to mention, we are not alone, of course, in the industry. We are talking to all the other companies, players, all the people, and we are in, let's say, quite good relations with them. We are actually their partners. We have partnerships with those major producers of software, and so we cooperate developing the BIM links. Regarding the customers that we have, there are some examples, or some of them are listed here in this tab. Well-known names. The thing is, next to that, what I'm trying to tell you, we provide or offer a great solution, great software, a great tool that nobody else has, which is all just fine, but the other part of the thing, or the business, or to make it work, is and that we also focus on a lot, is the technical support that we provide. This is being done by me and my teammates. We are a team of structure engineers in the department of sales and support of the company, and I believe we do a good job sorting those, technical support tickets and questions and so on. Usually it works that if you submit a case, you get the answer the same or the very next day with the help. And besides that, of course, we provide tons and millions of support materials that's in the support center of our webpage. All kinds of tutorials, webinars, and whatever. But that's just usual stuff that all the softwares, developers provide. Regarding reporting and localization, as I said, we support various codes, Eurocode, Canadian code, American, and a couple of more. Various sets of materials, cross-section bolts. We've got libraries of that in the software. We've got different types of reports that you can use as an output from the software. You can modify the report as you wish, keep it just simple and short, or make it provide all the information that's in there, making it like 50 pages report. And you can also produce schemes of drawings. You can produce a 3D CAD model out of the design that you create in IDEA StatiCa. This is how the report looks like. It covers nothing special. It just covers all the things that you would guess it should be there. Everything is displayed. And almost at the end of this presentation, just to mention, we release 2 major releases each year, in autumn and in spring. There we release new functionalities, new features, improvements. And if I haven't still convinced you about the potential and the greatness of the software, just try it yourself. Based on the experience, we can say that almost all the customers or people that tried the software understood the potential and the power of the tool, of the software. And because it's pretty simple to use, that's another big advantage. You don't have to really spend hours of training and I don't know, like workshops and courses for that. You just start with tutorial on your own, and it's very easy. I'll show you in a minute. Of course, you're encouraged to try the free trial. You'll find it on the webpage ideastatica.com, all for free. Just fill a form. You get immediately a license activation code or account that you use, and you can start in a minute using the software. Pretty easy. So that was it. That was the presentation part. Now, let me show you how the software looks like. So if I go to this is the starting application. Here you can select each of the applications. So connection, you start in here. This is opening for like a couple of seconds. I have opened one window here in advance. And so this works like this, that you select here the code, some kind of starting information. There you have the template. So you can just select one, any of those. So for example, we'll take this one. And now you create, the software creates the model. Right, this is prepared. Now you've got a 3D window here where you can, control the visual, and you can select anything in here and modify, edit, do whatever you like. So you've got like 3 main things to do here. You've got the members, the columns and beams. You can control in here. You've got the load effects that mean the nodal internal forces that you input, and then you've got the operations. Those are all the parts on all the connections. And now you can do whatever you like, right? So here, I don't know, I can turn on, turn off the stiffeners. I can modify its thickness. I can change the direction, rotation of those members. You can see the fin plate just matches to the new shape or topology, as well as the stiffeners. You can, of course, change the cross-section. So for example, I'll just go ahead and delete the stiffener and say I want a hello section instead for the column. So you can select here, there's a huge library of cross sections for the rolled ones, for the welded ones, cold form. There's even a timber, a simple timber application as well. And of course, you can create your own cross section. You can do whatever you like. You can also import a cross section from DXF, from CAD. So I'll just pick some of the square. You can assign favorites here or whatever. So let me pick one. No, I'm just guessing now here. This one, for example. Okay. And you can decide, okay, I'm just modeling now some kind of say second floor of the structure, and if I decide this is going to be the roof, so I can switch here to end it, rotate. Oh, sorry. Rotate this one like this. Make it longer by using cut operation, and in such a manner you can have a roof of a column. You can say this is going to be perpendicular, and I know create a cap on the top of the column to cover it. And I don't know, you can add more members in here. Let's say I'm going to add sorry, another in here. I can use again whatever. And using the right click, I can go ahead and select some template. In this case, there is not yet any template suitable for such a connection. It doesn't matter, I can just do it like this. For example, modeling a fin plate. Choose this one, connecting to this one, you know, and play with it like this. Make it bigger. Say it's going to be 1 bolt, and like this. I guess you're getting the idea, so I'm going to you know show more. This is now how you do the job. As I said, you can always optimize. If I calculate this now here, this is how you input the forces. You can use an Excel import, so you don't have to type those. Or, as I mentioned, if you use the BIM link, you get all the forces from your structure model. So let me just input something in here and let it calculate, so I can show you the output. There on the ribbon, there's a couple of icons. There's not much, because the philosophy of the software is to keep it as simple as possible for the use. So you can control here your project items. You can have more within one file, one project. You can have more joints or connections or nodes stored in here. Well, this is now overloaded, so I will input lower forces, because I don't want to. When it's overloaded, it will still provide you the results, but it takes a longer time to calculate it. Then you have, of course, you can turn on off, you know, some infos and so on. create pictures on the way of your workflow. You can create templates. For example, if you design such a connection, you can create and store it, the template within your software installation, and then you can use it anytime later again if you have the same topology of any connection. There you have a simple code setup. This is recommended not to modify, but if you want to experiment, you're free to do so. You can change all parameters of the model and mesh and the safety factors and other things in here. But this is the default settings which was verified, and this is what we recommend to use. Calculate button, and there you have those icons to import the forces, add loads, operations, members, and so on. You can use the right clicks everywhere as well. So now, since this is calculated, you can go to the check tab, and here you can browse the results, see the strain check, where the strain occurs. This is happening here, the lower flange or the plate in here. You can turn on the equivalent stress, the distribution of stresses on the joint, and turn on the mesh and deformed shaped. This is, let's say, just a simple tool to visualize and control. It doesn't tell you really how much of the deformation you have of each component, because this is not what the software is created for. This is created for code checking details. So where are the code checks? They are stored in here. For example, if I'm interested in this weld, I can click on that, and here in the right tab I see the overall information, the details of the weld and how it's doing regarding the check. You can see the distribution of the stress along the weld and its position in the model and so on. And you can open here to go through the details. So here you see the equation from the code for the weld resistance. All the factors, all the values listed and described. If I go ahead and I'm interested in, for example, bolt, let's see what it tells me. We've got all the code checks listed in here. For plates, this is just simple. It checks the maximum strain on each plate and displays just the simple values. Now the report, just briefly, nothing special. To be honest, it's just the report with everything listed. You can play with this, what you want inside, if you want all the formulas or just part of them. If you want to add pictures, bill of material, which means, if I refresh this, we've got the sketches of the plates for the workshop, for example, and all the checks listed. looks like this. You can export those these reports to doc and edit it further, or PDF or print out. You can export those drawings or sketches to DXF and so on. And the last tab here is materials. Again, there's a library of the standard steel materials, bolt grades, and bolt assemblies. And you can, of course, modify everything you like. You can add your own material, add your own bolts. If I go back here to design, I didn't mention that, how the bolt library looks like. This is what you get, of course. And now, this is, since you calculate and analyze, code check such a connection, you can say, okay, this is looking good, and I can do whatever here, any change I like. You can change, you know, thickness of this weld, thickness of those plates, and you can, again, I'll try to reduce the amount. You can do it in here, or I can go to editor and edit these bolts like this and just calculate right away. Nothing goes wrong with the model. You don't have to be afraid by, you know, that the model will fall apart, which I remember is happening in some of the softwares when you start to edit a finished model. It just stops working, and this is not, this never happens here. This is very you know, open for any editing and so on. I remember my struggling with my final thesis at the time, you know, when I was a student. I was modeling with finite elements on structure, and it was always like spending days of creating the model, and then if you want to change something, you had to almost start from scratch again. And so nothing like that in here. So that's how it feels, how it looks like. Let me maybe, I don't know how much time left we've got. I've got first information about something like 1.5 hour, 1 hour. It's
we're still fine. Was there something else you wanted to show?
Well, maybe just 5 more minutes to show you how the BIM links work.
Sounds good.
Yeah, with Tekla. Just briefly to so you see how it looks like. So I've got some kind of steel structure in Tekla Structures 2020 version. When you install IDEA StatiCa, it adds this ribbon commands into your Tekla, Code Check Manager, and Export the Viewer. This is an online application that you can, you know, when you're a designer, you can export this to online browser application, which is for free, and you can share the design in our application with anybody who's interested or who you want to show, for example, this connection. And then if you want to analyze the detail, you open this Code Check Manager. That's, let's say, the tool that brings the data from Tekla to IDEA StatiCa. Again, select the code. We've got a couple of flags in here already, so I'll go for the Canadian one. This is always when you start a new export from a new project. And here you say, I want a connection, find the structure node or intersection point, select the beams, select the parts of connection. Here it asks you to recognize the steel or translate, because this is, yeah, I forgot to mention this. This is a project in Tekla in Eurocode, so with European materials, but you can translate them or transfer into the US or Canadian material models or grades. So that's now being done. In the manager, you can of course export more nodes, and then selecting one would, you know, highlight the one that is selected. And here you can do a couple of things, like, for example, open the node, and you can also directly calculate if you previously opened and input some forces in the model. Synchronize, that means if you change anything in Tekla, you just click synchronize and it uploads or updates your model in IDEA StatiCa without deleting the load effects, for example. So if you've got, for example, 20 connections exported here listed, you have already input all the load effects, you have calculated all of them, and then you went back during the design process of the structure, you went back to Tekla and you modified, I know, thicknesses of plates, positions of bolts, stiffeners, or whatever. You just click synchronize all, it uploads, updates all the data in all your 20 connections, and just click calculate all, and it shows you if you are okay, if you are passing the code checks even with this new modified design. So you don't have to go one by one and, you know, repeat so on. Another really great time saver. So here I am. Here I got this from Tekla. All plates, bolts, welds in there. What I have to do is to input the load effects. Oh, sorry, I misclicked. So I can click, for example, here to add a load effect, and I don't know, I'll just input something. I don't care. And that's it, and you calculate this right away. As I mentioned, you can merge similar imported model that you get from your structural software. For this, you use this command connection import, find the file of the import from ETAPS, for example, and it would add you here, I know, like 20 combinations that would match this model, and just calculate, wait for, I know, 5-10 minutes to analyze all of them and just see the results. Yeah, that's pretty it. If I close this, you've got the information stored, the overview in here. And I don't know, maybe the last thing, that's the web page, ideastatica.com. All information you want, trial in here. Sorry if you hear a strange sound, that's that's my dog. That's my thirsty dog, because I'm I'm sitting at home. In the support center, I want to show you, if you want to start using, just go in here. Here you've got the theoretical background verification articles. If you're interested how the weld model is created and validated, go ahead and read all of them, or just, you know, pick some tutorial. For example, the one I was talking about, combination Tekla and SAP 2000. It's all described here step by step, or you can just start with an easy one. Just some kind of
I know
whatever.
when I was going through the training on, I found the campus, your IDEA StatiCa campus.
Oh yes, oh yeah, I would forget about that. Thanks for thanks for that. This is we provide a couple of tutorials just simply just to say step by step you follow this, and it's like, you know, you go through very easily to get the job done. And thanks for mentioning campus. It's an online training course. This is for anybody interested in you know, learning or becoming a professional professional designer of steel connections in IDEA StatiCa connection software. So it's an online course. It includes covers pretty everything from the very beginning, you know, like the how to handle the software, how to do things, and then also it goes into all the topics regarding design, those code checks, and I don't know, just go through everything. There you've got videos, materials, tests. There's, I think, like 11 lectures. At the end, when you finish, you've got a certificate, nice things to show to your potential employers, and yeah, that's it. It's the course is paid, but for students and academical stuff, it's I'm not sure now if it's for free or for some very very much discounted price, so very reasonable, and yeah, it's a good tool. Yeah, I think that's that would be it from my side. Now, okay. I'm ready to discuss, answer, hopefully everything that came to your mind.
Well, now that we know that you're expecting a new version in October, we're probably very busy. So now I'm especially appreciative to take this time for us. So thanks again. Yeah, and Adam has offered to answer a few questions. So I think we'll be really informal about this. Feel free to just turn on your mic and ask, or if you're an introvert, you can type it into the chat, and I'll moderate any of those questions. Okay, so we have our first question already. I see there's a timber section. Ahmed, I'm not surprised you're asking this question. Is the software have the ability to capture interaction between the timber beam and the self-tapping screws? Interaction.
Yeah, well, regarding the timber, I can show you this right away, how it looks like. This is, let's say, to be honest, we're at the beginning with the timber. We've developed, let's say, like starting like basics of that. You can model these timber sections or timber members and connect them with these gusset plates and the bolts. And what it tells you can show you right away. I think this would be quick. We focus for now pretty much on the steel part. So of course you check the plates, and for the bolts that you asked, for now we're kind of getting the feedback because the timber is new from the version 20, so it's like a half a year new feature. So we're retrieving getting the feedback on this feature, and according to this, we're going to develop more. So for now, it's just very simple like this. You just read the shear forces of each bolt, and they are not really code checked for now. So this is still limited.
Okay. Any other questions? Like I said, feel free to just turn on your mic and ask if that's preferred. Maybe I could just ask a question myself, because this was something that came up. It's kind of specific, but we were just looking at a very simple shear connection, shear tab, and noticed that when the bolts were checked for shear failure, the load was was not distributed the same to each bolt. It would be based on deformations.
Mm-hmm.
So when we looked at the bearing, they were all exactly the same. So I guess the question is, how is bearing treated when you're calculating the bearing on the steel behind the bolt?
Okay, well, maybe let's someone something like that. Let's just pick some of, well, maybe this one, and just apply shear. Could it be such an example? Do you think this would?
Sure, maybe with some more bolts.
Oh, some more.
Yeah, because
okay.
It was the distribution of the force among the different bolts, and just comparing the shear in the bolt check and the bolt bearing check. In one case, they were not distributed equally, and in the other case, they were. So I just wondered how bearing is treated in that way.
Okay. Well, that's a good question. It's first of all, it's different from the analytical model, right? Because when you have the analytical, you've got the distribution according to, it's spread equally, or according to some kind of procedure. And here each bolt or force in each bolt is calculated or calculated separately based on the stresses generated in plates and in those members. So if I take a look, for example, in the bolt forces, in this way you can see the stress in the plates, and also in this picture the, let's say, directions of the forces in each bolt, right, and their magnitudes.
So yeah, this is a good example. So under BR, they're all identical, like there's not any variation at all. So is there some assumption that it enforces that to be correct, or does it do something to make the bearing oh, that's the bearing resistance. Where's the bearing force?
Okay, you've got here it shows you, calculates you the tangent force in each bolt and the shear force in the shear plane.
Okay.
And then it's compared to the bearing resistance
I see.
calculated based on the code.
Okay.
And the thing is that, yeah, it's the for each ball it's there's a bit, let's say, non-uniform because it respects the behavior of the joint, right? So if I take a look at the deformed shape and I just multiply the visualization, here you can see all these bendings and you know, deformation movement. So it's not equal, right? And this is respected, and those are actually, sometimes you can see, as I mentioned, those prying forces. If you take a simple example of for example, a fin plate, and you apply tension on the beam connected to a column of a fin plate, you may end up with much higher forces in the balls than you would calculate with the analytical model or approach. And this is because this CBFEM model respects the deformation behavior and adds these extra prying forces
Right.
that are
Okay.
applied as well.
Yeah, I confess I have only just begun to look at the software. I think I might have misinterpreted the results. So I'm going to take my question back with me and figure it out because.
Okay.
Okay.
No problem. I mean, that was actually, if I may ask a question, have
Sure.
you, if there's anybody from the audience, if it's completely new for you, or if you have ever met or seen the software or heard about the method or something like that?
I think I'm kind of biased when I say that I've used it.
Okay.
Yeah, we know Ron has used it. And I think I can say that probably there are a lot of engineers who are not aware of it. However, you know, I think that it does have unique capabilities. So I think it's definitely worth having a look. And that's one of the reasons why we're doing it at the Steel Center, is to see how that could fit in with some of the other work that we're doing in
Cool.
generative design.
Yeah, well, I can't really comment on the engineering side of it, as I'm not an engineer, but as a huge fan of 3D modeling, I absolutely love the modeling engine that they built in there for building these components.
Right.
Really like the fact that I can go from Tekla structures in and bring a connection in, because I can model a connection in Tekla crazy fast, which is really nice. But the templates and the ability to build your own template connections, components inside of it to reuse later on, and just how simple it is to build connections, is really like that side of it. Again, I can't speak to the engineering side of it. Don't know a whole lot about that side of it, but the modeling side is really nice to use.
Oh, thank you.
Okay. So we'll. Oh, wait a minute. I do see another.
Yeah, go
Okay,
ahead.
no, just some comments about completely new or have used it with typical connections. Okay, so there's a variety of experiences so far, but certainly I find it really interesting in terms of its capabilities. So we'll have to study it some more. Any final question? We're going to wind it up. If not, then let me again express our appreciation for spending the time. And now it's almost 10 in the evening, I think, for you.
Yes.
So thank you for that. And I did notice that we have a participant here from as far away as Serbia. So I think the whole
Oh, cool.
a former
That's nice.
student at the University of Alberta, so he's kept in touch, which is fantastic. So
Cool.
maybe the Steel for Lunch is becoming more widely known now. So that's good to hear. So thanks again, and I appreciate your taking the time.
Thank you very much for the invitation. It was exciting to spend the evening here with you. That was really cool. Like,
Okay,
thank you.
So I'll just before we sign off, just remind everybody that the Steel for Lunch is by the Steel Center. Steel Center has as its members the companies that you see on the screen right now. It's very important that we acknowledge the support of these industry people, including Building Point, who helped to set this up for us, which we appreciate, and including the CISC. So next week we have a seminar by S-Frame on staged construction analysis and steel design. So we encourage everybody to join us for that a week from today. So thanks everyone, and good night to some and good afternoon to others.
Enjoy Friday and the weekend. And
thanks.
Enjoy lunch, actually.
Of course.
Bye-bye.
Bye-bye. Bye-bye.
Bye.